In a previous video, I showed you how to collect acceleration data while you changed the amount of mass hanging off the end of a hanger and kept the total mass in the system constant. We did this by taking discs off of a cart and putting them onto the end of a hanger. In this video, I'll be showing you how to go from the raw data, the data that you measured, to a formal data table where we calculate values that we are interested in. In particular, we're interested in the net force exerted on the system, which can be computed from our hanger mass. And I also want to give you an example of what to write down for your sample calculations for the formal data table. So, the formal data we need is we're going to want to convert the hanger mass from grams to kilograms, and then with that hanger mass in kilograms, we'll need to compute the net force exerted on the system. So, let's start by doing this conversion. I'm going to convert 20 grams to kilograms. Over here, we're going to write down a sample calculation. And we're going to do this for hanger mass from grams to kilograms. So that's the calculation we are doing. We should start by writing down the calculation we're doing. And then the way you do that is you start with your 20 grams of mass. That's this mass right here. And you multiply it by a conversion factor. The conversion factor we are multiplying it by is that there are 1,000 grams, so that's going to go in our denominator, per 1 kilogram. And we're going to double check our units. We do grams in the numerator here, divided by grams in the denominator here. That cancels, and we'll be left just with kilograms in the end, which is what we are interested in. So we're going to write an equal sign, carry this over a little bit so you can see it on the screen. I'm going to grab my calculator. I'm going to take 20 grams multiplied by 1 divided by 1 kilogram per 1,000 grams. Press enter, and that is 0.02. Keeping sig figs, I want to keep 2 sig figs, 0.020 kilograms. There we go. Of course, that is the same as doing 20 grams divided by 1,000. So you could do it that way too. And I now have a sample calculation for how to convert my mass hanger in grams, or my hanger mass in grams, to my hanger mass in kilograms. So that's 0.020. And then the others I don't need to show a calculation for. If you do that in your calculator, right, 40 divided by 1,000 will be 0.040 kilograms, and so on. You'll do that with the rest of your data. Now, how do we compute the net force exerted on the system from the hanger mass? Well, let's go ahead and do that sample calculation together next. So, the net force calculation. We're going to start by expressing our thinking in variables. The net force exerted on the system is equal to the gravitational force on the hanger by the Earth. See the pre-lab for more information about that. And we know that the gravitational force on the hanger by the Earth, its magnitude is equal to the mass of the hanger times the Earth's gravitational field strength. So, if we turn this net force equation from a vector equation into a scalar equation, the net force is the gravitational force on the hanger by the Earth, and the gravitational force on the hanger by the Earth, its magnitude is mg. We put those together, and we have that the net force exerted on the system is equal to the mass of the hanger multiplied by the Earth's gravitational field strength. So there's our general equation. And now we can do a specific sample calculation with this 0.020 kilogram mass. The net force in this case must be 0.020 kilograms for the first trial, multiplied by the Earth's gravitational field strength of 9.81 newtons per kilogram. So the net force exerted on the system, grabbing my calculator, is 0.020 multiplied by 9.81. And when I press enter, I get a net force of 0.1962 newtons. And I can go ahead and add that into my calculated column here. This net force was 0.1962 newtons. There we go. And now I have a sample calculation. So I don't need to show how I'm going to calculate the net force anymore, but I do need to compute it. So I'll grab my calculator again, and I'm going to take the mass of the hanger, in this case, 0.040 kilograms, and multiply by the Earth's gravitational field strength of 9.81 newtons per kilogram. Sorry, not divide, 0.040, multiply by 9.81 newtons per kilogram. And you end up with a mass of 0.3924. I don't need to show that work because I already showed a sample calculation for the previous data point. And you'll go ahead and do that. I only have 2 data points here, but you'll do it for all of the data points you have. And then the acceleration, that's the same. So I'm just going to copy that from the table up here and move them down here. So 0.5501, 1.089. And there we go. So in your lab report, I'd expect to see a sample calculation like this. You can either type it up in Google Docs, or you can handwrite it, take a picture, upload that picture to the Google Doc. And then in the end, we're going to plot a graph of the acceleration versus the net force. In other words, this column is going on one of your axes, the net force exerted on the system, and this column is going on the other axis. I want you to think about, though, this order, acceleration versus net force, which quantity goes on which axis. So there we go. There's how we're going to create our formal data table from our raw data. You're going to show sample calculations like this. You're going to fill in your formal data table, and in the end, you'll get the 2 columns that you need to make your plot. If you have any questions, let me know.